Hello, welcome to CM Square Learning Center. In today's chemistry lesson, I'm going to talk about topic 10, Organic Chemistry SL part. It's an alcohol oxidations. I chose this past paper questions from 2017 November paper 2, time zone 0 and question 6. The reactivity of organic compounds depends on the nature and the position of their functional group. So give you hints that the position of their functional groups. So let's look at compound A and compound B. They are both alcohol. They have a hydroxyl functional group, but they are structurally different. Compound A is a secondary alcohol because there are two alkyl chains that's bonded to this carbon, while compound B is a tertiary alcohol because we find that there are three alkyl chains that's bonded to this carbon. So in your IB syllabus for topic 10, Organic Chemistry SL, for alcohol, there are two reactions used low. The first one is oxidations. And the second one is esterifications. Let me talk about esterification first. Esterification is a reaction between an alcohol and carboxylic acid. And these two compounds react to form an ester and water as a side product. But since this reaction has no color change, so I think we cannot use a esterification to distinguish compound A and compound B. So let's eliminate the esterifications. And the only reaction is oxidation now. Let's look at part 1 questions. Deduce the type of chemical reaction. So the first part, the type of chemical reaction, and the reagent used to distinguish between these two compounds. So the first part, we can write down the reaction is an oxidation reactions. For oxidation reaction, we have to add the oxidizing agent, and that's the reagent used. And you should know the reagent is oxidizing agent, which is acidified potassium dichromate. Or you can write acidified dichromate ion. So that's all for part 1. And part 2, state the observation expected for each reaction given your reasons. So for oxidation of alcohol, there are 3 kinds of alcohol. The first one is a primary, and then secondary, and tertiary. Let me talk about tertiary reaction, tertiary alcohol first. Tertiary alcohol will not undergo oxidation, but primary alcohol will oxidize to aldehyde. Under distillations. And the oxidizing agent required is acidified dichromate ion. Also, aldehyde can be further oxidized to carboxylic acid as an end product. And we have to heat it under reflux. So the condition is heat under reflux. And the oxidizing agent required is the same. It's an acidified dichromate ion. For a secondary alcohol, it will be oxidized to ketone. So let me draw the structural formula for aldehyde and ketone. So ketone with a C double bond O between the two alkyl chain. Where aldehyde is a C double bond O, the left hand side is a H hydrogen atoms, and the right hand side is a alkyl chain. For carboxylic acid, it's N with C double bond O OH, and it's bonded to an alkyl chain. The secondary alcohol can be oxidized to ketone. The condition is heat under reflux. And the oxidizing agent required is the same. It's an acidified dichromate ion. Now let's look at compound A and compound B. So as I mentioned before, compound A is a secondary alcohol and compound B is a tertiary alcohol. So that means Compound A will undergo an oxidation reaction and it is oxidized to ketone. But what can we observe? Maybe some students know that secondary alcohol, it will oxidize to a ketone. And the oxidizing agent is a potassium dichromate or the dichromate ion here. And it will reduce to a chromium-free ions. So in this reduction, there's some color change. You know the color of a dichromate ion is an orange, while the color of a chromium-free ion is green color. So now you can write the answer for compound A. The color changed from orange to green. The orange color because of the dichromate ion. And the green color is because of the formation of chromium-free ions. For compound B, since it's a tertiary alcohol, and there's no oxidation for a tertiary alcohol, so we can say there's no color change.